For more information, please visit SGMAK Associates website.
This model is an example of a Monte Carlo simulation used to estimate the value of constant pi. Pi is defined as the half of the ratio of circumference of a circle to its radius. This is an example of Monte Carlo simulation since, unlike a dynamic model, passage of time plays no role in the model. Each entity represents a trial to select randomly a point inside a square of side R. The x-coordinate and the y-coordinate of the point are selected randomly. The origin is set at the lower left corner of the square. Following selection of a point, a check is made whether the point is inside or on the quadrant of a circle of radius r that has been inscribed in the square. A counter is incremented if the point lies inside or on the circle, and then the entity is disposed. A batch size is specified in the simulation model. Batch size decides how many entities are to be tried to be used in that particular simulation run. The last entity of the batch is used to estimate the value of pi by using the following relation. Pi is given by 4 times of the ratio of number of points inside or on the circle divided by total number of points tried, or equal to 4 times number of points inside or on the circle divided by the batch size. A larger batch size is expected to provide more accurate estimation of pi. Once again, this is a very simple example, shows a sampling experiment, and a Monte Carlo example, also known as a static simulation, because we are not interested in any dynamic behavior of the system. We have a simple task of selecting randomly a certain number of points and checking whether each point is within a circle or not, and estimating based on the outcome. So once again, Monte Carlo simulation model. Later on, we'll describe other interesting Monte Carlo simulation models. Hi, we are posting materials online. If you have any doubts or any questions regarding the
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.